That's fine. Idle speed control. In this case, there's nothing enabled here, neither open or closed loop, because we don't have that selected. We actually don't have an idle control populated and configured in the output setup. So this is fine. Main idle target table. Now we do want to program an idle target table. This is based on drive speed versus engine temp. I'm going to simplify this. I'm going to go here into A, get rid of drive speed, and just base this on engine temperature. This is going to allow the idle spark feedback to work and give a target for it to actually run at in order to move the spark timing around to get us to the desired target speed. So on a warm idle here, I'm going to say from, let's say 50 Celsius and warm, or 1200 RPM. I probably can't idle much lower with these big throttle blades at about 1200. That's where we're going to put the idle speed at, just as a guess. On a cold temperature, I'll say 1400 RPM would be fine if I'm warming up. And between 20 and 50 Celsius, I'll do an interpolation and allow it to slowly work its way down to a lower idle speed as the engine is warm. Use our escape key initial position table. This is not going to be applicable, so we can just zero it out. This is all based on percentage duty cycle control. For an idle control motor, that's not applicable to us. Target offsets, again, these aren't going to be anything we need to worry about, because this is going to be all used for airflow offset. If you're a stepper motor or you're a pulse width modulated control, idle control motor, we don't have that. We don't have any idle control. The only thing we really need to worry about here is setting up our idle target table, because the idle target is used in our spark timing feedback, which we'll find here under idle ignition control. Idle ignition control setup here, we do want it on. Now what we need to consider here is the low and the high clamp. I'm going to allow it to go down to -5 degrees as the lowest spark timing it's able to run itself to, and 20 degrees here as the highest. So this is going to be the range of adjustment it can work in for the idle ignition control. Again, it's going to take a look at the target idle RPM, and it's going to compare it to the actual idle RPM. Depending on how far we're off, that's the range of spark timing it can adjust itself in to get to the target. Let's go here to our idle ignition lockouts. If our throttle position goes above 2%, it kicks out of this control. Speed channel, we want to go ahead and turn this off. We want to set this to 0. I don't have a speed sensor. We don't want the speed sensor being a factor here in turning off the idle control. Idle control lockout range, I'm going to say 1000 RPM. So it's going to control everything up to 2200. Anything above that, it'll kick it out. Actually, you know what? Let's tighten that down here. Let's do 700 RPM. So if our 1200 RPM is our desired speed, it can run and target up to, in this case, an offset 1900 RPM. Let's do 600 RPM. So it'll be 1800 RPM. So 1200 is the target, desired target. It can control the spark timing feedback up to 1800. Now the reason why I don't want this too high is because if I'm decelling back into idle, it might try to yank the spark timing out and causing stalling conditions. I have to be kind of mindful of that. Post-start delay, we'll wait 5 seconds for it to do anything. Re-entry delay after we've exceeded the conditions to come back into the idle control. We'll wait 1 second, so that should be fine. Now, base idle spark. This is where we need to be careful. This is going to command our actual spark timing in idle conditions. Now, this table is based on idle target RPM error versus the rate of change in RPM. I want to keep this simple. And in fact, what I'm going to do under this idle target RPM, I'm going to just change all my values to the same value. I'm going to say I want to start off here with a value of something like 20 degrees. This is going to be my base timing, and then it can alter the spark timing feedback in that -5 to 20 degree range. So it can either add or subtract from the values in here. These are base values. Because we're going to be having just a fixed airflow coming in, will allow that spark timing feedback to do its thing. But this will be our base. 20 degrees, we can even lower it down, let's say 15 degrees, will be our base. So what this is going to say is this is going to be where it starts for the spark timing control, and then it can adjust from that point. So if we're decelling down into idle, 15 degrees of spark timing will keep the engine from stalling, and then it can start to make its adjustments after about a 1 or 2 second window. It'll start to try to reduce the spark timing down. I am going to go ahead and simplify this table and get rid of the delta change in RPM and just keep this based purely on idle target error. And what I could actually do in here to keep this even more simplistic, instead of doing it based on idle target error, we can type in here.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.